In this part of the lesson, we're going to take a look at our JCD Lite templates. Now, you usually see me using the generic template, and sometimes the basic closed solitaire. Now we're going to take a look at the rest of them. Okay, they can be useful during our designing, and they're often a good starting point for our designs. So we know not to use the default template. Okay, with this template we will not get access to the JCD Lite tools. Our basic closed 3 stone is the first template, and we'll take a look at this one now. So it's closed, meaning that the ring shank is closed. It is a full turn. There is no opening in the ring shank. 3 stone, meaning we're going to have 3 stones on the ring. Okay, I'm not going to name my parts since I won't be saving them. We're just taking a look at these templates. Okay, so here we are with our 3 stone closed template. Now, first of all, at the top you can see these 3 datums. These are the datums that are intended for placing stones on, hence 3 stone template. Okay, we have plenty of other datums, points, curve and sketches going on in this template. Okay, more specifically, in the middle here we have 2 curves, 2 arcs. Let's highlight them blank. Okay, we also have a curve list of those 2 arcs. So the blue one is the curve list of those 2 curves. Let's blank that out. And finally we have a sketch here. This sketch. Okay, and this is the ring sketch. You can see it in the history manager here, the ring size sketch. Now the purpose of this sketch is to place these points and these datums, and if we turn on the dimensions of this sketch, okay, they look quite complicated here, but each of these dimensions are linked up to the positioning of these red points, these little red dots, and subsequently the datums. Okay, so you'll notice that some of our points do not have datums on them. Okay, so these points here have datums on them, but we have points coming around the outside here. The purpose of these points is to allow us to place a curve on them so that we have an inside and an outside curve for our ring shank, which we can then use with the Rail Loft command. Okay, so the purpose of these points is to come in with a 3-point curve, okay, and snap to these points, because we're creating an outside curve that can be used with the Rail Loft command. Okay, and we'll take a look at the Rail Loft command later on in this lesson. Okay, we'll want to have a closed curve. Okay, and the Rail Loft and these 2 curves will give us more control over our ring shank. Okay, so I should point out here in the history we have all of our operations within this template folder. If you want to build up our operations outside of the template folder, we need to press play again, and you'll see the model stop jump to the left. Press play, the model stop jumps to the left, and now we'll be producing our operations outside of this folder. Okay, so you may find yourself encountering this at some point. Okay, it's not a big deal, but it helps with organization. Okay, so now let's see how these dimensions can affect our datums and our curves. So they may look quite intimidating right now, but if you look closely you will find they are rather simple. They all relate to our points and subsequently the positioning of our datums. Okay, so if we change our entity filter onto dimension, okay, we have this first dimension here. This is going to change the height of this point and subsequently the datums and that curve point. Okay, this is the datum that we use to place the center stone on. Okay, so by changing this dimension we can increase or decrease the height of that gemstone above the ring finger. Again, of course, we can insert a variable. Okay, which we can then link up to this value. Okay, obviously we have to come into the sketch environment, show dimensions, right click, modify, is selecting a variable to link it up to our center stone height from finger. Okay, it's linked up, we can exit back out into our part level, attributes, part, driving parameters. Okay, there's a few in here, we'll just bring our new variable in there. Okay, now we have control of it from here. Okay, so we have these dimensions everywhere. We have these ones here controlling the side stone, distance from the finger. Okay, this dimension is controlling this datum here. Again, we can modify these dimensions to make changes to our outside curve. Okay, we can also change the position of these points using our angles. Okay, it's changing them on both sides. Okay, and this angle here will relate to the position of our side stones. Okay, so the Rail Loft command that we use with the outside curve, I will show you this later on, like I said. For now I'm going to erase this curve. Okay, now let's place some stones I should say, on our datums. Okay, so let's place the center stone, let's say about a 2.5 carat round diamond. Okay, let's place a couple of baguettes as well. Let's say 5 by 3, about a 1/4 carat on our side stone datums. Confirm the operation. Okay, so that is the purpose of these datums within our template. If we show our dimensions again, move our gemstone with it. So let's drop down our center stone height, say 5. Okay, we didn't set up variables for our side stones. Okay, let's unblank our curves. We're going to hide the dimensions again. Let's place some bezels. In fact, let's place some wire settings on these stones. We'll start off with the round wire setting. The gem length was 8.8. Preview, we're going to place it on the same datum as the stone. Okay, I'm going to go through this quickly, just make a few tweaks, but if you were doing this yourself, or if you were producing an actual piece for manufacture, spend a bit more time than I'm doing so right now. I'm just going to increase this a bit, drop down the bezel length below girdle. Let's take the bend down, the bend of our prongs, and increase the bottom bezel height, the bottom section of the bezel there. Okay, that will do. Don't want to tweak, let's place a wire setting for our baguette as well. Let's find the baguette. That's tapered baguette, we want just the baguette. Okay, it's around here. Gem length is 5 by 3. Preview. Let's place it on the same datum plane. Yeah, I'll take the bend out again. Let's drop down the bezel length below the girdle. Top bezel height, I'll drop it down, and the bottom bezel height. Okay, don't want to tweak. Right, like I said, you might want to take a bit more time here. These aren't perfect. These set here, let's merge them both. Shape, we'll merge them both together, but as bases. We'll mirror. This setting across the side plane. Okay, our wire settings come in several parts. We can combine, add them, coming in several parts so we can erase certain bits of it. Okay, so if you can see here, maybe you want to bring in our side stones and the wire settings so that they touch our center stone. Let's show our dimensions again. This angle, change our entity filter dimension, change the angle, let's bring it in. Okay, bring it in quite a bit there. Okay, I'm going to leave it at that. Maybe it's a little bit too much, but I'll live with it for now. Okay, so you can see how we're building up our ring here pretty easily using our template. And the template also gives us the control over the placement of our stones. Okay, so that is one of the reasons they're so useful. Okay, next up, let's just quickly drop in a ring shank to finish this off. Any will do. Just put it in at the bottom here. Okay, these seem like decent enough dimensions. Do a shape, we'll do a sweep. The profile is the sketch. Let's pick it as a sketch to be sure. The path, now we can pick several paths here. If we set our entity filter onto curve, we could pick the half curves, the arcs. Okay, just wanting to pick the curve in the sketch there as well. Remember, we can use the Alt button to sift between entities that are on top of one another. Okay, so we use these arcs to get the half curves. We could use the sketch. Okay, but it's generally best, I find, to use the curve list if you want to get the full rotation. Confirm the operation. Okay, so you might want to trim this ring shank out now to the settings. Let's just do that quickly. Trim, pick the base, it's our shanks. Trimming to, well, set our entity filter onto shape. Let's just pick all of these. And see how it goes. We'll keep the trimming shapes just in case it erases bits that we don't want. Okay, now let's blank out this ring shank. We'll blank out our settings as well, so that we can see the excess material that we have. Let's get those back prongs there. Blank. Okay, so here's our excess material. Let's just pick it all and erase it. Then we'll unblank all. Extrude. Do an extrude cut. Okay, so that's quickly creating a ring there using our 3-stone template. Okay, and of course we can come into our Design Sketches ring tab, we have control over the ring size as well. Okay, so if we want to drop it down to 7 at the moment by default, okay, we could drop it down to a 6. Drops down to a 6. Okay, we may have to move these out a bit, they're getting a bit too close now. Their settings are too close together. Again, how about we increase it to a 9? Okay, there's something going on here. Sometimes you'll see that when you regenerate your history, that the original feature, the original setting, component, has come in again and it's not disappearing. If this happens, simply swap the entity visibility, come back in and it will disappear. Okay, so that's just a small glitch there. Okay, so this is our ring size 9. We've got a gap here, we'd need to move in our settings. It's very easy to do. Go into our template sketch and we just need to drop this in. Say 45 will probably be enough. Okay, that's happened again. Again, there you go. We have the control there. Okay, so that's just a quick example of using the 3-stone close ring template. Let's create a new part. Okay, below our basic closed 3-stone template we have the 5-stone. This is pretty much the same, except obviously we have 5 stones instead of 3. And you can see 1, 2, 3, 4, 5 datums for our stones. Okay, the rest is set up the same. We just have added dimensions for these extra stones. Okay, I'm going to exit this one. Don't save the changes, create a new file. Okay, next let's take a look at our basic close. Let's drag this box out to see the full name. Square bottom, top. Okay, so this means we have a square bottom and top for our ring template. Okay, you can see it here. We have the same sort of thing though with our ring sketch. Okay, and all the dimensions. We can change the position of our datums. This is a 1-stone template for a 1-stone ring. Okay, we have the center stone there. You have control over the angles, the position of these points. Okay, let's quickly throw in some ring shanks. Say a couple of these, top and the bottom. We'll drop down the dimensions of our bottom ring shank. Delay the solve. Okay, I forgot to turn off delay solve. I just regenerate here. Okay, and it updates. Okay, I should point out actually the options up here for our regeneration. We have regen. This is automatic regeneration when we perform a command. Okay, we can also opt to regenerate our part manually. Okay, so instead of the regeneration you see sometimes after you perform an operation, we can do it manually ourselves by just clicking here. Okay, so that's the difference between these two. Okay, you might want to keep the regeneration manually if you have a particularly large history that takes a long time to regenerate. You don't want it to be regenerating every time you perform a single operation. Okay, so let's now do a drive curve loft. Pick our curve list first as the driving curve, pick the profiles, the sketches. Remember, pick them at the same point. Confirm the operation. Okay, and here you can see our square shank at the top and at the bottom. Okay, we have control over our positions. Okay, let me turn off this dimensions here because we have one more thing in the history. This is our corner radius edit. Okay, we can make modifications to the radius of our corner. Within here, this is just a chain fillet in the template history. Let's say we change the radius to 5 millimeters. regenerate. Okay, you can see it rounds off our edges more. How about we drop it down to 1? Smaller radius will have more abrupt edges there, and you can see the change. Okay, so this is our square ring shank 1 stone template. Okay, create a new part. Okay, we've got the basic closed solitaire, as we've seen it before. It's just our very basic template. Next up in our templates list, we have a basic closed solitaire out path. Okay, and I'll show you this later on in the lesson. The out path is basically like the one we created, the second outside curve we created in our first example. Again, you use the Rail Loft command for this. Okay, so we will take a look at this later, and also our Rail Loft command. Okay, so next up, the basic closed solitaire square bottom. Okay, square bottom. Before we had square bottom and top. Okay, so pretty obvious. Here we just have a square bottom, not a square top. Again, you can see in our history we have control over the left and the right radius fillets. Okay, so I won't cover this. It's pretty intuitive here. New file. Let's move on. Let's increase this so we can see all of our templates. Okay, so we've been through here. We move on to our open templates now. Basic open 3 stone. Okay, so this is different from the closed. Our ring shank curves are open. Let's create it. Okay, we're creating an open ring shank. Okay, it's not closed, a complete rotation. And as you can see in this template, we already have a couple of ring shanks thrown in here already. Let's mirror this one across our side plane. Perform a drive curve loft. Pick the driving curve. Then we'll pick the sketches as the profiles, picking them at the same points, same places on each sketch. Okay, let's add the end caps for the end of our ring shank. Okay, there is our open ring shank. Okay, if you want to change the ring shank shape, you can come in prior to the loft, go to our design sketches and ring tab, ring shanks. Now a feature in this command, instead of placing them on points, is that we can replace sketches. Okay, so we could replace our previous sketches with the new ring shank sketch. Replaces them like that. Edit the loft, you're going to have to re-pick them. There you go, it's fairly simple. Okay, now we still have the ring sketch, but it is currently blanked out. Let's show dimensions to see that sketch again. Okay, and this sketch controls the dimensions over the same points. Our datums, our center stones, our side stones. Okay, but this time we also have this important dimension here, which controls the location or how far around our open ring shank goes. Okay, so if we modify this, let's increase it to 70. Okay, you can see that our opening has gotten smaller there. So this is the difference between the open and closed templates. Okay, let's create a new part. Look at our next template. Okay, so we just saw the basic open 3 stone. Next is the 5 stone. Okay, this is pretty obvious. Instead of 3 stones, we have 5 stones. Same thing. Open. You can blank out. There you go. We have our 5 stone datums. We have our curve for our open ring shank. Okay, we'll exit out of this, create a new part, move on. Basic open solitaire. Okay, so we have our basic closed solitaire. Basic open solitaire is an open ring, 1 stone. New part. Okay, now the last of our basic templates, the ones we haven't looked at, the basic closed solitaire out path, basic open solitaire out path. Okay, so you can see these will be the same, only one is open. Okay, now the out path, like I said before, this outside curve that we drew ourselves before. Okay, but this time it comes in automatically. Let's show our dimensions for our ring sketch. Okay, so like I said, we use these two curves, the outer curve and inner curve, with a bi-rail loft to get more control over the shape of our ring shank. Okay, now let's look at our bi-rail loft. Here's the bi-rail loft. It's like the drive curve loft, only we have two paths. Two paths. Okay, we will sweep a sketch, a ring shank sketch around them. Okay, now the important thing, the ring shank sketch, it needs to be in contact with both the upper path, the outer path, and the inner path. Okay, so let's insert some ring shank sketches. Okay, let's use a ring shank sketch with a comfort fit. Let's just go with this first one. Place it on our top datum, bottom datum, or I should say 12 o'clock datum, 6 o'clock datum. Confirm the operation. Okay, now like I said, for the bi-rail loft to work, we need our sketch, our profile, to be touching both the outer and the inner path. Okay, by coincidence, they are already touching. If they weren't, you might want to change the dimensions so that they do link up. Okay, but you don't want to keep doing this. So how do we link them up so that they always stay connected, even if we change the position of our outer curve? Okay, well, to do this, we enter into the sketch level of our ring shank sketch. Okay, we then reference. Okay, we use the fourth referencing option, our curve intersection. We pick the curve, the outer curve. Okay, if you can't pick it, come into the entity filter, select curve, pick the curve, throws in a little red triangle at the intersection point. Now we can show target. Okay, so we want to link this top point up to here. To do this, let's delete this dimension so that we can have control. Okay, now we can come in and constrain this point to our reference point. We'll use the point to midpoint constraint, but you'll need to use a constraint that applies depending on your ring shank sketch. You might need to use the point to line / curve or point coincident constraint. In this case, we'll use point to midpoint, pick our two outside points. The midpoint is that. Okay, so now it's linked up. If we exit our sketch, if we were to increase the dimensions, change the dimensions of the outer curve here, let's increase it to 4. Okay, that sketch is staying linked up to it, exactly how we want. Okay, let's do the same for the bottom sketch, the 6 o'clock ring shank sketch. Right click, reference, our fourth method, entity filter set to curve, pick the outer curve, we show the target. Okay, now we don't have to delete this dimension, we can change it to a reference dimension. Okay, so now we can drag it and it's not prohibiting us from doing so. Do the same method, point to midpoint. Okay, now we want to decrease this. Okay, but how about we want it to stay linked up in relation to this dimension? Okay, well, we have the dimension here, it's a reference dimension. We could drop this down. Okay, but we want to link it up. We could raise this. We could say that we want it always to stay to a value of this over 2. Okay, so now it will always be this value, this height, divided by 2. Okay, let's exit back out into our part level. Now let's use our bi-rail loft. Shape, bi-rail loft, Here we pick our first path, the outer curve, second path, pick the inner curve, the curve list, so they start from the same point. Profiles are our sketches, okay, and like before we pick them from the same points on our sketches. Now you'll see, even though I picked that side, it's going to change the location of our arrow. Okay, it doesn't matter as long as you're picking them at the same point and that our arrows correspond. Okay, as long as it is like that, then we have a good bi-rail loft there. Let's confirm the operation. Okay, here's our bi-rail loft of the ring shank. How about if I compare it? Let me just keep the curves. We need to blank out this shape. And this time we'll just do a drive curve loft with our inner curve only. Profiles, sketches. Let's move it. Oops. Right click, blank entities, unblank all. Okay, you can see the difference there between our bi-rail loft and our drive curve loft. Using our same inner path and the same profiles, we get a different result because we have the control with our outer curve for the bi-rail loft. Okay, and it does open up the doorway for design. We can create some pretty interesting shapes. Okay, so let's make some changes. Let's come before our bi-rail loft. Okay, this is a curve, remember. I'm going to hide the dimensions here. This is a curve, 3D curve, so we can double click to modify it. Use the modify command. Let's come into a front view. Why don't we drag out these control points a bit? Like this. Confirm the operation. Let's play the bi-rail loft. Okay, look at the interesting shapes we have there. Keep playing to see our equivalent drive curve loft. I'm going to modify this bi-rail loft actually. Now there's a setting, you can see it's all a bit off here. The setting maintain profile height. It's going to keep the profile height the same all the way around. There are a few other options and settings here. We don't really need to change or play around with these. We will, however, learn about our connection lines at a later time. Our connection lines help us when we may have, for example, different shaped ring shanks. Okay, let's confirm the operation. Right, so you can see the added control we have by using the bi-rail loft and this outer curve. Okay, it does open up the doorway for some pretty interesting modifications. Here we can make some more organic looking shapes. Okay, so it can be just a case of playing around until you see something interesting that you like the look of. Okay, so that is our outer path template and our bi-rail loft. If we look at our next template, the last one in our basic, it's the basic open solitaire outer path. Okay, so this is the same, apart from we have an open ring shank as opposed to a closed one. We will still use the bi-rail loft here. Okay, moving on in our templates list, we come to our elliptical templates. So our elliptical templates, they're pretty much the same as before, except of course our ring shank will be an ellipse as opposed to round. Okay, and all of these ellipse templates come with an outer curve, so we perform a bi-rail loft on them to produce our ring shank. Okay, so our ellipticals, we've seen their counterparts before in our basic templates. So we have a 3-stone closed, a 5-stone closed, same as our 3-stone, 5-stone basic, except we are elliptical. We have the solitaire 1-stone, and then we have our open 1-stone, 3-stone, 5-stone. Okay, so they all have the elliptical shape. And we have our sketches with our dimensions that we can make changes to. Okay, and then we can perform our bi-rail lofts, picking our parts as the curves. Now we can actually blank out this sketch, perform the bi-rail loft again, picking our curve lists, and our profiles. Okay, you see here how we tried to pick on the same bottom part of our sketch, but it allows us to only pick on the sides. Just make sure that the arrows match up. Again, obviously you will see in the preview if your bi-rail loft is not right. Okay, so if you have the open shank, your bi-rail loft may not come in with the end caps. Okay, in which case we can add them in ourselves, it's not a problem. Okay, we can use our freeform tab. We could use end-sided patch, FEM patch, a ruled surface. There's many ways to go to fill up this space. Okay, another thing we could use in our heel ribbon tab. Okay, we haven't taken a look at this ribbon tab before, but we will at a later stage. Okay, so this heel tab contains tools that allow us to repair our designs. Okay, one that we could use here is our fill gap command. Okay, we can pick the edges. It will automatically chain pick the connected edges, confirm the operation, and it fills our gap, and we now have a closed shape. Okay, so this elliptical template, we still have our datums for the stones and our sketch to make modifications to the positions of our datums and points. Okay, but we also have our inner and outer arcs. We can play around with, double click to make modifications to a curve. Okay, moving on in our templates list, So the ellipticals, we haven't taken a close look at all of them, but they're intuitive. They're very similar to our closed. Okay, only they're elliptical shaped. Next we have our generic template. We know what this is, we use it all the time. It's just blank except for our global datums. Okay, so if you want to start off fresh with no template, you use the generic. Okay, it's called a template, just generic, to create a blank part with just the global datums. Okay, we'll cover our oval bracelet template last. Let's now look at our square templates. Okay, so these are in the same manner as our elliptical. Okay, we have closed 3, 5 and 1 stone templates, and then the open 3, 5 and 1. Same as elliptical, okay, except of course they are a square shape. Okay, we have a square bottom like this, and then we perform our Rail Loft with our ring shank sketches. Okay, so these are our square templates. Okay, so there's no need to go through all of these. Finally, we'll take a look at our oval bracelet template. If we open this up, it's a fairly simple one. Obviously it's larger dimensions than the rings. By default the rings are all a US size 7, so that's 17.3 millimeters in diameter of the ring finger. This bracelet size you can see is much larger, about 60 millimeters by 56. Okay, our bracelet sizes are often done in circumference, so to work this out we come into our Inquire tab, length. Here we can find the length of our bracelet here, left click. We can assign a variable to it. Let's just call it size millimeters. Confirm. Okay, you'll see the expression added to our expressions folder in the history manager, size in millimeters. If we make modifications to this, okay, the size is going to update. Okay, if you want to see this size in inches, we could insert a variable, a new variable. Let's call it size inches. Here in the expression, I know that there are 2.54 centimeters in every inch, or thereabouts, so that's 25.4 millimeters per inch. Okay, so what we do is we take this value, get variable, okay, the size in millimeters, divided by 25.4, okay, and there we go, we see our variable size in inches. Okay, so if we make another change here, let's increase it slightly. Okay, we see our size in millimeters update. If our size in inches variable does not update, right click, solve, and there it solved it, and update it to the size in inches. Okay, so these are our length and width dimensions. We also have some dimensions here. These are changing the offset of these points. Okay, the points are for use with an outer curve if you want to add one in. Okay, we don't have to. We can always just insert sketches and sweep them or drive curve them. Okay, if we want to use the Rail Loft to have more control, come in with our 3-point curve. Let's snap to our points. Okay, we want it closed like this. Okay, the degree, we can change the degree with a closed curve all the way up to the highest degree. This is going to make it more round. Okay, if we have our curve open, we cannot come up all the way. We cannot increase the degrees this far. We can only go to the degree. There's one less than the number of points that we have. But if we create the curve closed, we can increase it all the way up. Okay, confirm the operation. Let's throw in a quick ring shank to use as our profile for the bracelet. Let's just say one of these, we'll use a step one around here. Okay, obviously we're going to have to increase the sizes of these. In fact, I will just have one of them placed, so I'll undo the last one. Come in, double click, right click, reference, our fourth reference method, curve intersection, pick the curve. If you can't pick the curve, make sure your entity filter is set to curve. Show target, plane view. Okay, so we need to link up this up here, but we have two dimensions governing our sides here. So let's just turn this one into a reference dimension. Use our auto constraints. Okay, so we'd have to change this step size manually. You can always set up a variable to it. Okay, so let's just set it to be 1mm. Let's exit into our part level. Shape by Rail Loft. Pick our first path and second path. Going to pick them both as a curve. Okay, now we have an issue here. Okay, it might not actually be an issue in this case, but I would often want both of my paths to start at the same place, at the profile. Okay, let's see how this one works out. Okay, you can see it's not coming in correctly. Okay, so to correct this, we could create a new curve on top of this sketch. Okay, with a starting point up here. Alternatively, we could come in and redefine this curve. I'm going to unpick all. If we want it to start at this side, this is where we begin our picking. So where we begin the curve. Confirm the operation. Okay, our sketch. I usually like to have it at the same point as our starting points, but it doesn't actually matter here. Pick the first path, second path, the sketch. Okay, if we wanted to change the location of that sketch, we just simply replace it on this side datum, the 3 o'clock datum. Okay, but it doesn't matter here. Okay, so this is our bracelet template. Okay, we can play around with the curve, the outer curve, to make modifications to the shape of our shank. We can also play around with the datums, the offsets that we have there. For example here. We see it update. We could come in and let me just blank this out again. Open this up, we could change the degree here. Drop it down to 2. Regenerate. Okay, you can see the effect that it has. Okay, so we've seen here the templates for JCD Lite. There's quite a few of them, and they can be very useful for setting up our designs so that we can make modifications and create a vast variation of different shapes.